understand this. You now when you're doing vectors, right? Basic result, usually there are two main characters. So in this case, it's A and B. So everything can be expressed as A and B. The area under graph, the area of triangle, the plane equation, and so whatnot. They are all can be expressed in the form of A plus B, because it's just like in Cartesian diagram. Imagine that in secondary school, right, when you're doing Cartesian form, or I mean even now you use Cartesian form, right? You can express everything in terms. If I draw a triangle here, you can find the area here. You can even find an equation for x and y. The rationale is because you can mix and match x and y to achieve whatever you want. So it's the same thing. Instead of having the axes as x and y, right, you can have a and b like that. So now you have sort of like a slanted axis. Okay, just remember that. So in vectors, right, when we write in a and b, essentially we are saying it's like a Cartesian coordinate but slanted axis. So that's the main thing. So don't get too worried about it. So just now, one of you mentioned that it looks like a plane equation. It's correct. It's actually a plane equation. So r is 0, 0, 0 plus lambda. You can just add a 0, 0 here. Why? Because this is okay. This represents all the points on the plane which passes through the origin. Okay, and the plane have to remember so it's the same thing. You take a point, this is a point, you add a dimension, it becomes a line, right? So this is a line, they add another dimension, it becomes a plane. So this is a plane, and parallel to vectors A and B. But the important thing is where A is not parallel to B. A. So since C is on the plane, since C is on the plane, OA B, or you can write coplanar. The 1 mark is for the coplanar. So hence C is equals to, for some, C is equals to lambda A for some lambda mu real value. Okay. 1 mark, you don't need to write everything here, but this is as precise as you can get already. So I write down everything that I think is required. So this will be the point N AC side A and NC is 3:4. Throw it out. Correct? 3:4. Yeah. So AN by ratio theorem. Okay, you have the middle one. It's always a subject. ON is equals to A times 4, C times 3. Oh, that's about it. Add the ratio up. So, given that ONC, area of ONC is equal to area of OMC, where M is a midpoint of OB. So this case here, OM is half OB, not an issue. OM is half OB. Then by finding the area of this triangle in terms of A and B, find lambda mu. Okay, so that's okay. So part 3. Remember, your currency is A and B. So if you see C, right, you just get this out. Okay, your whole goal is to your Cartesian coordinate system now is in terms of A and B. So you just change it to A and B. It's given that area ONC is equal, so area of our triangle ONC, area of triangle OMC. Okay, ONC will just be half ON cross OC. This is half OM cross OC. Okay. And you just look at the diagram. ON. So just then the rest is just quite okay lah. ON we got it just now previously was at 4A 4A plus 3C. You see OM is half of B cross C. Okay. Cancel. Be mindful. 1/7 can bring it out. Then 4A cross C plus 3C cross C. Distribute it properly. Carefully. This is 0 vector. E cross C is 0 vector. The half is scalar, can bring it out. Remember, C is not A and B. So make sure you know your alphabets. So if you see C, bring A and B out. So C is equals to lambda A plus mu B. So this will be B cross with lambda A plus mu B. B 0.74. Same thing with this one, lambda A plus mu B. Half. This is 0 vector. Parallel vectors, when they cross, is 0. Same thing, slowly. Yep. 0 vector. You can skip step. I'm doing it very slowly so that we are all on the same page. We just bring it up. I'm gonna just flip this aside. So this can cancel away. Note this is another common misconception is that A cross B is equals to B cross A. But A cross B is not equals to B cross A. The mod is the same, but the cross product, you need to make sure you understand why. Okay, there's go. Anyway, from here, you just need to make sure lambda and mu are positive. But they already told you that lambda and mu are positive, right? So have to be careful about that. Usually, this case, you not so worrying because both are positive, so it's quite okay because it's given a question that mu or lambda are both positive. So you don't need to worry. You can just bring it out. So am I right? So what do we want? We want lambda in terms of